apologize for speaking yet again. You can tell that I'm extremely interested in the whole area of the cultural differences and similarities between music in different parts of the world, and also in the way that they express emotion. And I hope we're going to discuss this more in the breakout sessions. But I'm really learning an awful lot. And I wanted to see if I could put together some thoughts about the idea of music and movement. I'm grateful to Dr. Shetty. I think this was number 80,431 in your book. How to solve the mystery of music and its history. I talked yesterday to some extent about that, the campfire experience, which I'll very briefly just touch on again. But so here are some facts about rhythm that actually it's very difficult to define, but we all know what it is. Humans are the only species, the only living species to entrain to music over long periods of time. And I think this again needs some neurobiological explanation. And I don't have it. I have not yet worked it out. Obviously it's to do with alterations of basal ganglia, cortical connectivity, but I haven't been able to discern the difference between the hominid brains from the past and also ancient ancestors to put this into a meaningful expression. But if anybody can come up with a neuroscientific explanation that relates to neuroanatomy, I'd be grateful, because it is clearly something which is extremely important in terms of human cultural activity. We're the only species that spontaneously synchronizes to the beat of music. So as soon as you put on some music, people will start to move wherever you see it. Rhythms in music vary considerably. We've heard a little bit about this. But wherever you are, it appears to be the case that the rhythms and the beat of the music will entrain people to dance and bring together people in a dancing ensemble. I put here, rhythm is part of the expressive performance, and certainly as far as I can follow this in Western music, when you hear the waltz, it creates an entirely different emotional expression to when you hear the march. And of course the waltz is often associated with frivolity, with light music, but also with romance and something which perhaps is a little bit sinister sometimes in music. Whereas the march, of course, can be very sinister, marching music, entraining people to step in rhythm during the march as they go off to war to kill themselves or other people. So rhythm and the beat of music is extremely important. But what about the pace of breathing, the beat of the heart? These are the internal bodily rhythms. The rhythm of walking and entrainment. Now, it seems to me that entrainment relates to when exogenous exogenous and internal synchronization occurs, or where you get synchronization between two or more people. And it's the case that if you see couples walking along the road together, they tend after a few paces to take the same pace of walking and often use the same walking steps as if they are bodily walking together with the same kind of rhythm. Now, in terms of feeling rhythm and responding to another in rhythm, just to go back to those campfire experiences, it would seem to me that those individuals who are most skilled at sensing the meaning of others and expressing themselves in singing and dancing would have had some kind of evolutionary advantage. That's pure speculation, and again it comes to this issue that there are some people, neuroscientists, who maintain that the world would be entirely the same if we didn't have music. It's irrelevant, and the famous expression by Pinker is that music is like evolutionary cheesecake. It's sweet and it's nice to taste, but it hasn't made the slightest bit of difference to human evolution. I personally can't accept that. Some more possible facts. Speech has rhythm, and again, there are some people who are more rhythmic than others, but the rhythm of speech is reflected in poetry, but also there are the rhythms in music which go together with poetry. Now, something that is interesting, which is quite obvious, but I hadn't thought about it very much, and again, Nigel will help here and perhaps the discussions, but the rhythm of speech, resonant in individual cultures, also rebounds in the actual songs that are sung. And again, it's quite obvious, but I can't imagine that Wagner would have written The Barber of Seville, or that Rossini would have written Tristan and Isolde. And I have a problem when I go to hear German opera or Italian opera or French opera when it's been translated into English, because sometimes the music just doesn't fit the actual composition of the libretto. And now, maybe this is just me, but it actually seems to me that the individual music that you hear reflects the language that people use. So we can tell Russian music, we can tell Czech music, we can tell American music. I'm now beginning to be able to tell Indian music. And it interlinks somehow with the language, but I don't know exactly how, and maybe we could discuss that later. But it has to do also with rhythms. I put there, life is movement. When you think about it, everything living moves in some way or another. It goes back millions of years in evolution. Another one of Dr. Shetty's couplets, music and motion connected to emotion. And we've heard a little bit about that already. I've written there, no rhythm, no suspense, no drama. Again, the rhythm in the music that we hear is part of the suspense, and we've heard a little bit about reaching an ending particularly. But also the rhythm is a great deal to do with the drama, in particular opera, as it unfolds on the stage. I came across the comment that there was an Indian poet called Pingala. Now, here I am in India. Could you put up your hands if you know Pingala? Oh dear. Oh dear. Apparently he should be very famous. He was not quite sure when he was born or when he died, he's BC, but he discovered the so-called Fibonacci numbers well before Fibonacci did, probably 1,500 years later. And he was a poet. He's on the web, on Wikipedia. So I'm teaching you something about your own culture. Anyway, the Fibonacci numbers, they're just reflected there, where each one is the sum of the previous two. 1, 2 equals 3, 3, 2 equals 5, etc. Now, this is all interlinked with something called the golden ratio, and later, or perhaps then even referred to as the divine proportion. And I've written it down there, 1.168, and it's a continuous number. But Nigel was explaining to me more about this at dinner last night, and I hope we can discuss this a little bit more, because it has to do with the relationship between numbers and the composition of music. And numbers, of course, must also be interlinked with rhythm. And my understanding is that various artists, but also poets and composers, have used this Fibonacci number sequence when composing music. And Nigel refers me to in particular Debussy and Bartók. But it all reflects back in my mind to the issue of the link between mathematics and music, and I'm not a mathematician, and why Pythagoras was so important with his numerical basis of music, which seems to be the foundation, by and large, of certainly Western music, although it's been tempered with. To what extent are these principles, these mathematical principles, embedded in Indian music, is the question that I want to ask, because clearly this man, this poet, is very, very famous, or should be famous, for his discovery of these sequences which are used in Western music by some composers. So if we could just hold that as a discussion point later. And I've talked about the campfire experience and the way that when people were gathered in this close-knit community, surely one hypothesis for the development of not only singing but also dancing, and then later the development of storytelling, but the complex development of language must have evolved. We know that there are expressions of singing and dancing in art. This is rock art showing dancing and music in Madhya Pradesh. I've already shown it, but obviously music and dancing are part of very, very early cultures. As recently in Australia, it's very difficult to contact or understand what the Australian Aboriginal culture really was like many years ago. There's a superb book, a travel book by Bruce Chatwin about this, and I just got a quotation from his book there. At the moment there's a exhibition of Australian art in London, and I just took this picture from it, from Sydney Long. It's called The Spirit of the Plains. But the Aboriginal creation myths, and I'm just quoting here, sing the world into existence. And their paintings contain song lines. Now, when I was in Australia, I saw a lot of Aboriginal paintings, but nobody could describe them to me, because the Aboriginals keep it, as far as I can see, a secret as to what these mythologies are. But the idea that singing, dancing, and our exploration and living in nature is something which is still extant today in some cultures. I need to just talk a little bit about internal rhythms as opposed to external rhythms and linking with nature. And in an audience like this, I don't need to say very much about the autonomic nervous system, except to say that it is very often ignored in discussions of emotion. So if you look at textbooks and you look up limbic system, you might be told this is something to do with emotion. It's an archicortex. It's been driving emotional expression for millions of years, but it doesn't very often discuss what happens outside the limbic system. Now, Chris showed a nice image where you saw the limbic structures going out of amygdala and hippocampus, and then down. There's a tract called the medial forebrain bundle, and they go all the way down, he showed, to the brainstem. And what you have in the brainstem areas are the outlets for, I didn't discuss this and I don't want to go into it in any detail, but you have the outlets of the vagus nerve, and the vagus nerve we now know is afferent as well as efferent, and hence the gut feelings come from the vagus input to the brainstem areas here. And those brainstem areas, one of the nuclei is called the nucleus of the tractus solitarius, has a highway, a direct highway into the amygdala and the insula. So gut feelings get directly into the receptive parts of old cortex in terms of these feelings. The sympathetic system is obviously different to the parasympathetic system. Parasympathetic system, both of them influence heart rate, breathing, etc. But the sympathetic system is monitored somewhat separately by galvanic skin response, for example, the sweating of the palms. But the idea in the past was that the sympathetic and parasympathetic system were kind of yin and yang, and one went up, the other went down, whatever. But we now, I think, feel that's a rather naive way of understanding how the sympathetic system regulates our homeostasis on a not even hour to hour or minute to minute basis, but even perhaps on a second to second basis. And Nigel showed some interesting clips of heart rate changes yesterday, and I'll show you some of our studies in just a moment. But the sympathetic and the parasympathetic nervous system actually regulate the final common outpath to our emotional expression that relates to these gut feelings. So it's possible to monitor what goes on in the sympathetic nervous system. I've mentioned galvanic skin response, but you can obviously measure heart rate, you can measure breathing rate, you can measure pupil size on the eye, and you can measure, actually the group I've been working with have been developing something which measures those goosebumps, those feelings down the spine, which we haven't yet used in terms of musical feelings, but we hope to in the future. So the heart rate is linked with respiration. Again, we probably all know this, but if you actually just find your pulse, and do you all know where your pulse is? If you all put your hands on your pulse, and you take a big breath in, you find your pulse will increase. And as you breathe out, it just gets that bit slower. But the link between breathing and heart rate, there's autonomic, it's the autonomic reflex, can't get away from it, it's happening all the time. So these unconscious modulations of our autonomic nervous system, something that keeps us upright and acting all the time. Now, music affects the autonomic nervous system, and I want to just talk about entrainment a little bit more here, and looking at the links between an external stimulus and the autonomic system. But also, I want to just show an EEG study, which is not mine, but one which I find quite astonishing, and one which will be of interest, I think. Entrainment. Two oscillating systems assume the same period ratio, two people walking along together, two cerebral systems or two other systems. One could be exogenous and the other endogenous. And this was a paper that I came across, and I found it fascinating, very difficult to understand. But it is brain synchronization with music. Now, these authors took two guitarists, and measured the EEG. They monitored the EEG, and they were looking at EEG rhythms in two brains of two guitarists. And there's a lead guitarist who begins a piece, and they both play together. Now, what they showed was synchronization between the two guitarists' brains. So they're playing the same piece of music. Here, you see when the guitarist plucks the strings. And you see here, this is actually the theta rhythm. It's the slower rhythms. And I have to confess, the mathematics that goes into this paper is well beyond my understanding. I'm only showing you the images, which I think are fascinating. But the mathematics is beyond my understanding. But you can see guitarist A here actually begins the sequence and you can see a synchronization occurs very quickly in terms of the theta rhythms with the two people playing guitars. But what was most fascinating was the synchronization between the brains, guitarist A and guitarist B. And again, you see here the synchronization. Here's the start of the sequence, here are the plucks of the music, and you can see the synchronization. But when they actually then did very complicated mathematics and plotted the two brains through EEG synchrony seem not only to be synchronizing with the music, but synchronizing together. Now, again, I think this just bears discussion, and if anybody knows anything similar to this, I'd be fascinated to hear it. I just thought this was fairly remarkable. Sonification, melody analysis for predicting seizures, I put here. Now, there are a group of people, and Nigel is involved in this, and again in the discussions, I hope he will say much more about it. But there are people, I understand, who are attempting to take EEG rhythms and create musical structure from the EEG oscillations. Now, the paper that the person I've quoted there, which is Vikinanza, I'm afraid I read this in a sort of Sunday Times color supplement, and he doesn't appear to have published on it, and it's work in progress. But it is very interesting for the following reasons. If you can take EEG signals and create some kind of musical sequencing from that, can you then take the musical sequencing to play it back to alter cerebral rhythms? And in the line of this, I've come across two case reports. They're only case reports of patients who had epilepsy and were in non-convulsive status, who were not responding to medication, but did respond to, in the one case, Mozart's music, and the other case, Bach's music, when it was played to them on the intensive care unit for a prolonged period of time. I think it was overnight. Now, this may be extremely important, or it may not be, but it seems to me certainly worth exploring further in terms of the relationship between external stimuli and internal stimuli, internal oscillations and regulation of behavior through music. Another paper recently published looked at 11 adults singing in a choir. And they were looking at the way that the music structure that they were performing related to heart rate variability. Now, that's obviously one of the monitors of autonomic activity. And what they were doing, they gave people a task. One was humming. The second singing task was to sing a hymn. And the third one was to sing a mantra. And they were looking at some of these autonomic variables. And what was fascinating was that in a choir, unison singing of regular song structure led to alteration of heart rate and synchronization. So here you can see some examples. So here is the heart rate variability spectrum to humming and to singing a hymn. And what you see is that the spectrum, this of course is the mean spectrum, but you can see the variability of the group is huge. Whereas when they're singing a hymn, the heart rate variability is much closer to the mean. The variability is much less. They also showed the same with the respiratory spectrum, the breathing rate here, and the spectral density is clearly much less. So singing in a harmonious group leads to a coordination of some of these autonomic variables. And here is again another one. This is the baseline, again showing a lot of variability. Here is humming, with a lot of variability. This is the heart rate variability. But singing a hymn leads to much less variability in terms of the spectral density. And then in terms of mantras, again, the coordination is not so great as with hymn singing, but nevertheless, the mantra performance leads to some kind of coalescence of the singing and the music to the underlying autonomic variables. Now, this, of course, may be related to the fact that when you're singing, your breathing is in coordination with other people. So, but the music is bringing together a harmonious alteration of the autonomic nervous system in a choir setting. What we were very, very interested in was to look at this in somewhat of a different way. And I recently had the opportunity to carry out what can only be called an experiment. And we took two protagonists. One was an opera lover who went to opera a lot, and the other was somebody who was a football lover and had never been to the opera. And we took them to the Royal Opera House, and we had a box in the Royal Opera House. And it was a performance of Verdi's Simone Boccanegra, which is one of Verdi's more famous operas with some very, very glorious moments in it. It's a very complicated opera, actually, in terms of the story, which is quite important in what I'm going to show you, because the person who had never been to opera, I think, must have struggled to understand the story. It wasn't quite such a simple story, like say, a Madame Butterfly from Puccini or whatever. And we monitored various autonomic factors, and also they had an event monitor which they could push when they felt something was happening. We're still in the process of analyzing the data, but this is just a part of it I just wanted to show. And this shows the heart rate, the mean heart rate over a period of time. The opera is quite long, but we've done it by, there's a prologue to the opera, which you could call Act 1 if you want to, and then there's the 3 acts. And this is the mean heart rate of 2 different people sitting next to each other listening to Boccanegra. And we haven't done the precise statistics here, but you can see that over the course of the opera, the heart rate, as a good example of the autonomic nervous system, alters in precisely the same ways. Perhaps this is even more interesting. I want you to watch, as long as we can see this. I just want you to watch. By the way, you probably will not recognize the protagonists, or you may do, but I want you to watch the following. Oops, sorry, no, got to go back. Try again. Yeah. Whoops, sorry. There we go. And we can have the sound. Yeah. Sorry, if you could just click that one. Thank you. Oh, down there, sorry.
So
that's it.
We want to actually see the moment, both show the traces and the moment where our hearts go and sing. Please try not to laugh. And doofuses we appear to be. Oh dear.
I'll play it again anyway. Can you put it on again for me, please? Yeah. I think I must have just pushed the wrong button, but it's worth just seeing again. Now you've seen it. Okay, now you may know who the protagonists are. It's Stephen Fry and his friend Alan Davis. But again, just watch the close synchrony of their heart rates as the music progresses. And if I could monitor your heart rate during this piece, I'm sure you'd find it awesome. Got a little shiver. Somebody must have got a little shiver with that. I mean, this was, yes, Chris did, yes, that shiver. But again, the remarkable thing about that was these are two people, I guess they were sitting next to each other, but the heart rate variability, you could just see it changing in both of them moment by moment to the music. A very, very convincing demonstration of the way that opera can arouse people. Even Alan Davis, who'd never been to an opera before, and it was Stephen Fry is rather embarrassed because it looked as if he was going off to sleep, but because he wasn't, you could tell by his heart rate that he was actually in some kind of very, very important emotional state. But that variability, moment by moment, listening to music, and the synchronization between those two people is, I think, quite remarkable, and says something very important about the link between the musical synchronization of the oscillations in music to the oscillations in the brain, altering autonomic responses. So just to conclude, rhythm and our responses to it are facts of human life, and music is a part of the rhythm of life. Music has ancient origins with evolutionary significance, and what I've been trying to show here is that the music and the brain both enjoy oscillations, and I think somebody referred to this earlier on. Again, it might well have been Nigel who referred to the link, harmony, heavenly harmony, which does go back to the early origins of thinking about the relationship between the heavens and music, and a famous Dryden poem, a song for St. Cecilia's Day. From harmony, heavenly harmony, this universal frame began. From harmony to harmony, through all the compass of the notes it ran, the diapason closing full in man. Thank you. Do you want to have questions now, or is there something else? Oh, okay.